Hello everyone and welcome. In this lecture we will be covering the download of Unity, where you can find Unity, and then we will be creating a project and starting along with this course. So to get Unity, simply open up your preferred web browser. In my case I'm using Opera, and you can just type in unity3d.com and click enter. This will get you to their web page, and here we have many tabs. We can also learn more about Unity, but what interests us is this Get Unity button. So if we click this, it should redirect us to the store. And Unity is a free engine. It has a personal edition, which is free. You can download this. But we also have these Plus, Pro and Enterprise edition, which simply give us access to more features. For example, in the personal edition, here you can see everything that we get. So we can build for all platforms. It is royalty free. We get Unity ads, multiplayer, all those great things. But we won't get performance reporting, asset kits so if you purchase Plus or Pro, you get some of the most popular asset packs from the store. You get them for free. We won't get those. We also won't have source code access. We won't have editor UI skins, which doesn't really matter, and some other things here. But everything's fine. We can make full games in personal edition, but if we feel the need to upgrade to Plus or Pro later down the line, we can do that really simply. So just click here, try personal, and Unity will start downloading and installing. That process can take up a lot of time, so I already have Unity installed here. This is the latest version of Unity as of this point, 5.6, and I went ahead and clicked new to create a new project, and I'm going to create a new project here. I'll call it project 1. Also, we can say if this is going to be a 3D game or a 2D game. I'm going to set this to 3D. In this course, we won't be making any games. We will just be explaining Unity engine and C#, so how you can do a lot of cool things in the engine. We won't be actually developing any games. We have other courses on game development that you should check out if you're interested in that. But in this one we won't be making any games. We'll just be explaining things to you. So it doesn't really matter if you select 3D or 2D. But for the sake of it, I'm going to set this to 3D, and I won't import any asset packages, and now we'll disable Unity Analytics and just create the project. This should take a few moments for Unity to create the project and start up. Here we go. It is loading my extensions in the engine. You can see that many big companies use Unity. Blizzard made Hearthstone in Unity, Ubisoft uses Unity. Unity is a really great engine. And for some reason my engine has... whoop. Don't worry about that, there was some mistakes. And you can see that when you download and install Unity, your layout might look different from mine. So let's go to Window and Layouts. Yours, whoops, not like this. Yours should look, I think, default like this. So this is how Unity's default layout looks like. And we can easily change the layout by just dragging these tabs, for example project, and just putting it maybe here. We can also just customize the editor however we want. How I like to have my user interface here layout is, I like to have my hierarchy here, and down here I have my project assets, and right here I have my inspector tab, and here's my scene view, my game view, and the asset store. Another thing here in the assets browser, where we put our models, music, scripts, images, sprites, whatever. Here we can create a new folder, for example, by right clicking and going to create folder, and I can call this, for example, scripts. What I like to do here is you see we have this slider here, so I can increase and decrease the image size. I like to put it to minimum, so I have these nice folders and it's really easy to view. So thank you for watching, and we'll continue in the next lecture. That'll be it for this one, and see you in the next lecture. Hello and welcome back. So continuing, we have our scene view here, and this is basically where we can design our levels and our game. You can see that we have this light here and this camera, and also in our hierarchy we have our scene. This represents the scene. It's currently untitled, it doesn't have a name. That's because we didn't save it. And this scene currently contains the main camera and the directional light. We can press on each of these objects and we can see that in the inspector tab they have a few components. So each object has the transform component. Basically the transform component has the position, rotation and scale of the object. Now you can see that this camera is positioned on x0, y1 and z10, so I can move it around. You can see that in the same view we can actually see the camera moving around up and down, but in the camera preview we don't see any changes. That's because we're rendering a skybox and we currently have nothing in our game. So let's go ahead and create a game object here. Under hierarchy I can click create and 3D object, and we can create a cube. And here we see our cube. Now if we look at our main camera, we see that the camera preview is actually picking up on the cube here. Now if we go back to the game, basically the camera preview is what the user sees, so the game view. And now if we move the camera, we can see that the world is moving, the cube is going up and down. So basically whenever we're moving the camera, we're also moving the world. You can also think of it like that. You're either moving the camera or the world. And also the camera has the camera component. We can also, and each of these components has different parameters. For example, the camera has the clear flags. Currently we're rendering a skybox, so what you see now is the default Unity skybox here, the blue sky and this sort of grayish color, but we can set this to be a solid color. Now you see the camera preview in our game, we only have this. The color we can change it if we click on here and then just choose a different color. Let's go with something like this. But in our scene view we still have the default skybox. We can go ahead and click on this icon here, and we can just toggle the skybox to disable it, and now we have this dark wireframe just look, which I prefer when designing anything. We can also change the clear flags to be depth only, which only renders the depth, but I prefer it to be skybox or solid color, depends on what game you're building. Then we can also have the projection to be perspective. So basically if you look at the scene now, if we select our camera, you can see how we're projecting the camera. So basically this is all that the camera sees. Whatever object is in this range, the game is going to pick it up. If I change this to, if I change culling mask, actually projection to be orthographic, we have this kind of like orthographic view. And now if I move the camera, the position, even though this object should be rendered and should be decreasing in size since we're moving away from it, it isn't, because we're using orthographic projection. This is mostly used when building 2D games. I will set this back to perspective since we're working in a 3D environment. We also have a field of view slider. We can just increase it and decrease it to, as you can see, just play around with the field of view of the camera. I'll set it back to 60. The clipping planes is how close an object should be to the camera for it to start clipping. For example, if you're using a first person, if you're building a shooting game and you have a gun, you will need to play around with these values because the gun is right in front of the camera, and since it's that close, sometimes parts of the gun can be invisible, and you just play with the clipping planes to fix that. We will demonstrate that in a later tutorial. Currently we won't be doing that. We also have the viewport rectangle, which just leave it to default for now, and different kind of settings that we don't need to change currently. We have the graphic user interface layer, the flare layer, and the audio listener. Each scene should have a audio listener which basically picks up all the audio in the scene and plays it to the user. The audio listener is mostly on the camera, but it can be on different game objects. So moving on, our directional light, which is what emits the light in our scene, has of course again the transform component which each game object should have. And it also has the light component, which makes it so that this light can emit actual light. And you can see that this light is a directional light. We have the type here, and it is emitting light in this direction downwards. But you can also change it to be a point light, so you can see it now emits light in this area. We can also change it to be a spotlight, and you can of course play around with these values. You can see as I drag this in the scene, the values in the spot angle are changing. We can also increase the range here, and of course increase the color of this light. Then we have the mode of this light. Basically, if the light is rendered real time, or if it's pre-rendered, or if it's a mixture of both. We'll get into this later, but basically if your scene is static, so if you don't have moving objects, it's good to have the light pre-baked. But if you're going to have objects that are constantly moving around in the scene, you're gonna set real time, the mode to be real time, to render it in real time. Then we have shadow types, strengths, resolutions, and all things like that. So let's move on to our cube. As you can see, our cube also has the transform, but it also has a mesh filter. This is basically so we know what kind of mesh this cube has, and currently it is a cube. I can change this mesh to be capsule, plane, or whatever. But you can see as I change the mesh, we have this green outline. What that is the box collider. So if I disable it here, you can see now it kind of disappears faintly, but I'm going to re-enable it and set the mesh to our cube again. And our box collider is basically what enables this cube to interact with the world. So it will hit other objects that have box colliders. I'm going to demonstrate that. I will duplicate this cube and just drag it down. You can move things around in this scene by dragging them on these axes. I can now press R to resize this cube. Okay, just now in our game we can see how it looks. I'm going to select this cube and pull it up, and I'm going to demonstrate what these box colliders actually do. So I'm going to click add component to add a new component, and we will add a rigid body component. This is a component that you will be using a lot in game development. This basically allows the object to be interactable with physics. So now it has a mass, a drag, angular drag, and it is using gravity. So if I play, this cube should fall down and hit the ground. And it did just that. But if we disabled our box collider, it would fall through the ground, as you can see there. So it's really important to have box colliders on. We can also edit the box collider. For example, if I click edit, I can increase the size of this. Don't know why I would, but we can do it. Now this is a bad box collider for this object, but I'm just doing this to demonstrate to you that you can in fact edit them. And as you can see, the cube isn't really hitting the ground, but it's still stopped because it collided with it. with the ground. And another thing here you might have noticed is trigger. Basically, if we enable this collider will become a trigger, which means it will trigger events that we specify in scripts when something happens. When something enters this trigger. So if I enable this won't behave as a collider but as a trigger. So now it should fall down through our cube, but since we have no code to execute when something enters the trigger, nothing happens. So thank you for watching this lecture. We will continue in the next one. So see you then. Hello and welcome back. So last time we covered the components that each game object can and will have. These rigid bodies, box colliders, and other components are pre-made Unity components, so we can click add component and then we can search for them and add all sorts of different components to our game objects depending on what we need. Whoops, didn't want to add that, I'm going to remove that. But we can also create our own components, mainly in the form of scripts. So in here I have, in my assets folder, I have the scripts folder, which I'm going to now open by double clicking it, and we can actually create a new script here. So I'm going to go ahead and right click, go to create and C# script, and I'm going to call this maybe test script, and we can run this script by double clicking it. It will open Visual Studio for me because I have this set as my default text editor for Unity. In your case it might open up MonoDevelop. It doesn't really matter, they both will work the same. It's just that I like how Visual Studio looks like and I like using it. So this script that we just made, as soon as it opens, we can add it to a game object as a component, and it can have all sorts of different attributes just like other components have. So that's what I'm going to show you now. If we open up our script as soon as Visual Studio loads, this might take a while. This is why MonoDevelop is, well, it is faster to load than Visual Studio, but I just like using Visual Studio much more. As soon as this loads, we will continue. Okay. It's preparing our solution, our script. Anytime now. Okay, and here we see our script. I can zoom in by holding Control and scrolling up the mouse wheel. Ignore this. And you can see this is our class, our script that we just made called test script, and it's a mono behavior. And you can see that this script now, by default, we get these two methods, void start and void update. Start is, you can see we have void start, and then we have these curly brackets. That means whatever code is in between these curly brackets, it will be executed when the game starts. So that's basically what the start method does. And void update is it executes code inside of the curly brackets each frame of the game. So basically all the time. And above here we have imported, by default it imports these three libraries that we should use. And if you notice in Visual Studio, these two are kind of grayed out. That's because we don't have any code that is using them. We can delete them or keep them, doesn't really matter. What I want to show you now is we can, usually when you start programming in any kind of language, the first thing you do is print out hello world. So we can do that. We can go in void start and we can say debug.log, and in here we put in the string. So we use these parentheses to say that it's a string, so hello world. And of course we need to close a line of code with the semicolon. Now if I save this, and if I go back into Unity, and I got a warning because some line endings aren't compatible with Unix, but don't worry about that. So now we can choose one of our game objects to attach the script to. It doesn't really matter for now. Let's go ahead and add it to this cube. So just drag and drop it. Or we could also went to component and just typed in the name of our script. Now that this script is a component of this game object, if I run the game, we should get in our console hello world. And in fact we do. If you notice, we only got hello world once, and that's because the start method only executes once when the game starts. But if I take this code now, if I cut this line and go down into update and paste it in here, and if I save, now go back into Unity, again the same warning, you can ignore that, and I run, we should be getting hello world each frame. You see how we get 260 hello world debug.logs. But now you might be wondering, well, these other components have all of these different parameters that we can edit from the inspector. Can we do that with our scripts? Well, of course we can. Let's go back to our script. And all of these parameters are basically some kind of variables. So here, mass, drag, all of these are different variables. So let's go ahead and create a variable. For now, let's go ahead and say public string, and let's call this name. A public variable basically means that other game objects, other scripts can access this variable, and we can also edit it from the inspector. A string means that this variable is of type string. Strings are basically text, like hello world. And now instead of hello world, debugging hello world, we can debug name. Now if I save this and go back into Unity, if we would run the game, nothing would happen. Well, that's because our component test script currently has the name parameter. As you can see, you see how rigid body has these parameters. Now we also have the name parameter, and it's waiting for some kind of string. So let's say hello there, and now if I hit enter, if I run the game, we should be getting in here hello there, and we are in fact getting hello there. I can also change this on the inspector, like say hello, and as you can see, as I'm changing it, so it's updating in the game. You can see how, as I was typing it, it was debugging this because it is executing each frame, and as soon as I type something, it executes. We can also create references to other components, but I'll do that in the next lecture, since this one is getting a bit long and I don't want these lectures to be too long so that they don't feel too overwhelming. So I'll thank you for watching, and we'll see each other in the next lecture.